Swayam Prabha. Digital India. Educated India.
Hello students, welcome to lecture number 58 where we are talking about buildings with Diagrid frames. What are buildings with Diagrid frames and why do we need to talk about it now? We have already gone through a series of lectures where we talked about structural systems in buildings, in contemporary buildings starting from the modern times, how from a simple moment structural frame, how the structures have evolved. In tall buildings, this dull rectilinear skeleton has dominated the tall buildings for decades, but after several departures from the rectilinear skeleton, we have something completely new, and that is called the Diagrid frame. It's an accumulated result of these several experiments that were conducted, and this merged into the structural type called the Diagrid. What is the Diagrid? Diagrid is a combination of two words, diagonal plus grid, diagonal grid, which is widely used now in tall steel buildings for its structural efficiency and for its aesthetic potential. One ecological skyscraper that I studied with you earlier, the Gherkin, and the other building that I talked to you about with regard to being a green building, that is the Hearst Tower, both of them by Norman Foster have a Diagrid frame. It has a perimeter grid which is made up of a series of these triangular truss systems, and it is a very unique geometrical configuration which is formed by intersection of diagonal and horizontal components. Several examples of Diagrid structural systems are there that support challenging shapes. For example, the Gherkin, for example, the CCTV headquarters in China by Rem Koolhaas, the Bow in Canada by Norman Foster in 2012 are all examples of Diagrid frames. Then the Hearst Tower, Poly International Plaza in China by Skidmore, Owings and Merrill in 2017 are examples of Diagrid frames. The Capital Gate building in Abu Dhabi is a Diagrid frame. The 170 Amsterdam building is also a Diagrid frame, and so is the Seattle Central Library by Rem Koolhaas in 2004 are examples of Diagrid frame buildings. It has a triangular structure, the main triangular component along with horizontal support beams. So, for example, here in the Hearst Tower, we have the triangular component, the Diagrid, and the lower part there is this horizontal support beam. Now, in Diagrid, the members which form the triangles can either be straight, forming these sharp edged triangular frames as we see in the Hearst Tower. In fact, it is also true for the Gherkin, but there the building becomes like a torpedo. It has got this oval shape, but even in that shape the triangular frames are sharp edged and straight. In the Myzeel building, it is curved, which forms very smooth and flowing geometry as you see here. Both triangulations are achieved that gives a structure stiffness and load distribution efficiency. The difference is in the curved Diagrid, it is much more organic, it is much more free form. In the straight Diagrid, got a very straightforward and clear structural expression. In the Diagrid structural frame, the structural technology is a crossroad of engineering and architecture. It's got a tremendous architectural appeal, that is one of the reasons why architects have been attracted to it. The perimeter diagonals have very good structural efficiency, and this is a very new interest in designing tall structures because they have this lattice-like look as you see here in the Capital Gate building. So, Diagrid is structural integrity through the use of triangulation. It has been adopted in tall buildings due to its structural efficiency and flexibility in architectural planning, got very closely with regard to closely spaced vertical columns in frame tube structures or frame buildings. This is very different from the Diagrid structure, which has got these inclined columns on the exterior surface of the building. The lateral loads are borne by vertical columns in frame tube buildings, like for example we have the Seagram building, but they are resisted by axial action. That means the load transfer takes place axially in the diagonal direction in Diagrid structure, and I will show you that. So in 2001, Norman Foster designed two high profile projects in London and New York, the Gherkin in London, the Hearst Tower in New York. Both of them were different in silhouette. The Gherkin was more, like I said, like a slender torpedo, and the Hearst Tower was a 4-square ziggurat, and it had this kinch in all the corners. The Diagrid expressed in this triangular external struts is a promise of a very new kind of structural clarity in tall buildings. Together they mark the turning point for Diagrid. Since the two buildings have been built, many global projects by various architects has come up. For example, this Seattle Central Library just mentioned by Rem Koolhaas, again this CCTV headquarters by Rem Koolhaas, by RMJM Capitol Gate building, this Zaragoza Bridge Pavilion by Zaha Hadid, the Prada store in Japan by Herzog and de Meuron are all examples of the use of Diagrid frames in various ways. The essential physics of the Diagrid frame is it's a series of triangles that combine gravity and lateral load support into one. It makes the building stiff, efficient and lighter than conventional high-rise buildings that have got a frame construction. Mutually reinforcing and crisscrossing steel members are connected at specially joined nodes that, for example, you see here. This is the example of a node in the Hearst Tower. With this kind of exoskeleton, the architect is able to cut down on internal supports, and I will show you that. It saves space and building materials. We will reflect on that again. I have already mentioned it to you earlier in the Hearst Tower presentation. It allows for naturally broad apertures and provides greater flexibility for the installation of systems. So this is the Diagrid structure with the vertical columns from the periphery have been completely eliminated. This is how the entire structure is put together. You can look at this slide again to see the specific parts, but this is how the load transfer takes place. In the load transfer, under gravity load and wind load, both are transferred axially. So the dead load, that is the gravity load that is coming, is transferred axially. The wind or the lateral load coming on it is also transferred axially. The triangulated configuration is able to carry both gravity and lateral loads. This effectively minimizes shear deformation as diagonals are carrying the loads axially, and also reduces the amount of members needed to carry the load. Therefore, the material requirement, that is the steel requirement, also goes down. There are of course the issue of tie beams. We will not go into details, but you see here outside is the Diagrid frame. The tie beams are connecting the core to the Diagrid frame, and they are transferring load from the core to the Diagrid frame. Now the same thing also happens in moment frame. We have talked about it in detail in the lectures on structural systems. The force is also resisted by the ring beams, that is that I told you about between the triangular frames of the Diagrid. The ring beams are there, and the ring beams and tie beams are also resisting forces. Now the nodes are important part of the Diagrid. This is the node. If you go back again, I will again show you the node. This is the node that I was talking about here and here. These are the nodes. Now the nodes, all diagonal sections are connected to each other at the nodes. These nodes are designed for both vertical load and for horizontal shear. They are joined to other sections either by welding or bolting, and the vertical load transfer takes place as axial loads. As I just showed you, both gravity and lateral loads are axially transferred from the Diagrid members above the nodes, then transferred to the diagonal members below the nodes. So in 170 Amsterdam building by Handel Architects, the entire lateral system, the Diagrid system, is located on the exterior. That means the exterior has this Diagrid design. The fundamental advantage, one is of course the aesthetic appeal for architects. Also, the series of triangular components combine both gravity and lateral loads into one. Thus, it is an efficient design as lateral members are subject to tension and uplift forces. So, when uplift forces happen, the gravity load that is coming on it is able to counteract that. It allows the same member to take the gravity load acting in the opposite direction and greatly reduces both tension and uplift. because when the uplift forces are acting on the building, gravity loads are pushing them down, and both are happening axially. The reduction in terms of it makes a substantial impact on the sides and the reinforcement of columns, leading to tremendous saving in building materials. Now 170 Amsterdam is actually a successful implementation of the Diagrid using concrete. There are minimal, it also minimizes internal supports, as you see here in the interior, liberates the interior space and provides greater flexibility for the installation of systems, as I just mentioned to you. So these images actually show you how the interior spaces get freed up from internal supports. In the Hearst Tower, the first commercial office building that got a gold LEED certified rating in core and shell interiors, we talked about it. One of the reasons was the innovations which adhere to the principles of sustainable design and construction, and that was because of the Diagrid frame. As I mentioned to you in the earlier lecture, the Diagrid frame was not adopted with the understanding that it will reduce the requirement of steel, but that is what exactly happened. They were able to save up to 20% steel, that is about 2000 tons. So if the requirement of the steel in a conventional building, this requirement went down by nearly 2000 tons, and structural steel, over 90% of that used in this building was using recycled steel. So we both save on space, as I showed you in the 170 Amsterdam building, and we save on building materials. So Hearst Tower, the same thing is happening. So Foster's effort was to create a now in the Gherkin, when Norman Foster designed that, his effort was to create a sequence of skewed atria. We've talked about it in detail earlier, and this was to allow for natural ventilation and to also work as light wells. Thus that could cut down on energy consumption. Now such a system of atria could not have been possible if vertical column support systems were there. This was made possible because of the use of the Diagrid, because it eliminated the internal supports. Thus the Gherkin cut down on internal supports, as you can see in these images. As you can see in the top floor restaurant with the panoramic view that I talked about earlier, and the Diagrid allowed for this column free floor space in the Gherkin with fully glazed facade, opens the building to light and views. This is how naturally broad apertures were there in the Gherkin. We talked about these informal spaces that came out in the Gherkin, and these were spaces that people could gather within the atrium spaces. And the similar thing happened in Capital Gate in Abu Dhabi. With this configuration and efficiency, it reduced the number of structural elements required on the building facade. There was less obstruction to the view outside, and the interior and corner columns could be avoided, which allowed for tremendous flexibility in the floor plan, like it happened in the Gherkin, like it happened in the 170 Amsterdam building. Not only that, because of the Diagrid frame, not only are we able to get these larger spans and high-rise buildings, particularly when there are complex geometries and curved shapes. For example, this particular building. This is the Alder headquarters in Abu Dhabi. The Diagrid structure is very highly adaptable to wide range of building types, spans and forms. It provides structural support to non-rectilinear buildings and adapts very well to buildings which are highly angular or curved in form. For example, the Capital Gate building again. The system though is uneconomical after 70 stories, because then the joints become more complicated. So this is one limitation of the Diagrid frame design, that there is a restriction in the number of stories yet possible with the Diagrid frame. We do not know in the years to come that could be overcome. The three materials that we use in making the Diagrid frame, one is the structural Diagrid frame, which is most commonly and most popularly used. The weight and size of sections which are made to resist high bending loads, that the both of it goes down. There is quick erection, low cost of labor and installation. Second is concrete that is commonly used. It is precast and cast in situ both, as we saw in the 170 Amsterdam building. As precast concrete sections are flexible, allows them to be fit perfectly in the structure geometry, protects it from fire damages, but precast concrete constitutes more to the dead load of the structure. The third material is timber. It is used, for example, in this building here, it is the least used of all materials for making the Diagrid frame. The advantages are that the section of timber is easily available in any shape and size, and it has low installation cost, but the disadvantage is it has got less material strength, less durability, and has major weathering issues. The advantage of the Diagrid is, of course, besides the ones I mentioned, the complex built forms which lead to an improved aesthetic view of the building, which is very appealing to the architect. Second, I told you, is 20% reduction in the steel as compared to moment frame or brace frame structures, generous amount of light coming inside the building because there are lesser members on the outside, and there are column free exteriors and column free interiors which are free and clear. As a result, unique floor plans are possible. The disadvantages are also there. It is still not been completely explored. It needs skilled labor, and currently the present crews that are on site, working on site, lack experience in installing Diagrids. It completely takes over the aesthetic appearance of the building. The design is limited only to the Diagrid. The common language of floor to floor design is affected, as the single Diagrid can be up to 4 to 6 stories high. And if it is not properly designed or installed, it affects both the economy and safety of the structure. In conclusion, it is with the new and complex geometries that are emerging from the design profession in the last 2 decades, this is the driving force behind buildings that are using Diagrid. In all the 5 buildings that I am again repeating in this slide, all of them have complex geometries. The Seattle Central Library, the CCTV headquarters, this bridge by Zaha Hadid, the Capitol Gate building, and the Prada building by Herzog and de Meuron, Japan. The Diagrid is a very forthright presentation of the grid, and it is very dramatic architectural appearance. It is an image of sustainability. It helps form an understanding of what environmentally sensitive buildings could look like. Schwitter, who is the managing director for design consultant at Buro Happold, says the Diagrid is an advertisement of material saving and green benefits of the buildings that are using it. That's where a building like Hearst looks like an energy efficient design, and it is actually energy efficient. Diagrid is slowly replacing the modernist box design, and we are moving more and more into this innovative structural frame. For example, the Yes Hotel in Abu Dhabi by Asymptote Architecture has got a vast Diagrid screen that alts up and down over the main body of the hotel. The firm principal Hani Rashid connects the use of Diagrid to the possibilities unleashed by digital design techniques, and he says the remarkable possibilities to optimize and parametrically control the design of buildings. We didn't even have this possibility 5 to 6 years ago. Of course, this statement was said several years earlier, so we can say that about several more years have passed by since this statement, but Diagrid are playing a major role in many of the buildings being designed today. This is the pictures of the Yas Hotel in Abu Dhabi by Asymptote Architecture, and this is the Bridge Pavilion in Zaragoza by Zaha Hadid. The Diagrid approach is diffusing through architectural practice and is filtering down to builders and fabricators and becoming more and more a conventional technique in building design. For example, again the CCTV headquarters, the erection is getting easier, it is getting more efficient even in complex forms and geometries. Thus, to conclude, the Diagrid frame integrates form and structure, it unifies aesthetic and engineering, its diagonal geometry expresses the structure itself. It's got structural efficiency. The Diagrid members are carrying both the gravity and the lateral loads together, transferring them axially. reducing the need for separate columns and braces required for gravity and lateral loads. The material and energy savings that take place, optimized load paths lead to 15 to 25% less steel requirement and a more sustainable construction, greater architectural flexibility as it enables free floor plans, a very distinctive facade, greater penetration of natural light into the buildings, and taller and more expressive buildings are being made using the Diagrid structural frame. Thank you.